I'm here to talk about architects, right? And as many people know, architects are some of the more illustrious characters in software engineering, right? Like some people say, like, you need to have a great architect, to make a project succeed. Other people say, architects, they just draw pictures, and if you're lucky, they don't interfere with your project too much, right? So there's very different views what these architects are and what they do. So one thing I want to talk about is a lot of people have the opinion that architects live in their own little world, right? They're kind of somewhere. And I think that's actually true. And I think the world they live in is the world of the first derivative. And I'll explain what I mean by that. First, though, I want to talk a little bit about architect personas, and you kind of probably got a glimpse of this as I was playing with the video, right? When we think about an architect, sort of in a tech community, usually this guy comes to mind, right? It's like, and his name is the architect, right, obviously, and makes all the decisions, knows everything, the ultimate authority, right, speaks in these like long logical sequences. And that sounds really impressive. It has one major drawback, and that is this is not a human being, right? This is part of the machines. We know the Matrix, right? The humans versus the machines. So this is the machines. This is great in the movies. It's not as great in real life. And you guys know I like to make movie references. So a movie that's lesser known is this one that also has an architect, and this is out of High Rise. This is Anthony Royal. Very different architect figure. And this is the architect who has this sort of ideal, this utopian vision of what the building architecture should look like. Has this amazing roof garden on top with horses and all sorts of stuff. But the whole thing goes totally, utterly haywire and wrong and ends up in absolute mayhem. So any similarities to actual IT projects and the influence architects have, of course, total coincidence. When people see me as an architect, right, and I play architect's roles, I'm now working for the Singapore government, actually, working on the cloud architecture. So when people see me as an architect, often this guy comes to mind. A little bit sort of the mad scientist type. And I always say it has a little bit to do with the haircut, and it has a tiny bit to do with the car I have, right? So there's some similarities here. And I think a tiny bit of mad science in architecture is actually a good thing. Right, a little bit of disturbance. So with that sort of having looked at the wide spectrum of what architects are, before we can talk about the first derivative, I think it's good to understand why we have architecture. And then I also want to talk about when don't we need architecture at all. And I thought about this quite a bit and came to the realization that the main role of architecture, at least in a larger context, is actually this. Right? And it's fairly obvious what that is. Right? To the financial people, this is as obvious as Docker and Kubernetes is to us. This is Black-Scholes. This is options pricing. Right? Architecture creates and sells options to the business. Right? Like options, we know from the financial side, an option is a way that you can defer a decision into the future. You can buy yourself the option to buy a certain stock, let's say at $100 in a year's time, right? So you defer that decision of whether you buy the stock or not into the future by 1 year, but you fix the parameters, right? It's still $100. Now, when the year comes, making that decision has become very easy, right? Because if you can buy this stock for $100, if it trades at more than $100, you have money in the bank, right? You buy it for $100, you sell it at the market price, right? The decision is very easy in the future because all the information is there. You know the stock price 1 year from now. If you need to decide whether to buy the stock today, you don't know what's going to happen, right? So deferring decisions into the future gives you more information, makes decisions much easier, and therefore has a value. Right? And it also, everything that has a value generally has a price. And this is exactly what architecture does. And the example I like to give from the IT side is a decision that I like to defer into the future is server sizing. Right? We just heard about serverless and automatic scaling, the little billing accidents aside, right? So the server sizing we can defer into the future. Like I used to work in a large IT, they had a whole team doing nothing but sizing servers. Right? And everybody knows server sizing has a big problem, and that is it only has one of two possible outcomes. Right? The one is too small, and the other one is too large. right? So either your application doesn't run really well or you wasted money. Nobody's ever happy. Now, we as architects know exactly the option we can create and sell to defer that decision into the future. It's called elastic infrastructure, scale out, serverless, right? These are exactly the mechanisms we have. And the reason that has a value is because I defer decision into the future. And again, once the future comes, the decision is very easy to make, right? I need a bit more capacity, I scale up. I have excess capacity, I scale down. And quite honestly, it also has a price. Right, we saw like Chris had to like re-architect and redo the application a little bit, right? You need to run on the proper infrastructure, have some modularity, have a scale-out architecture. The option is not for free. So should the business buy the option? That is a question for the business, right? As an architect, I can offer the option for sale, but whether the option is valuable for the business or not is hard for me as an architect alone to decide. Right? I think scale-out architectures on serverless and elastic infrastructures are a great thing, right? But I may or may not need this. So interestingly, one aspect that very much affects the price of these options, and that's right in this formula, is the letter sigma there. It's actually a sigma square up there, and that's the volatility. Right? And this is Black-Scholes. They got a Nobel Prize for economics for this kind of stuff. But basically, the higher the volatility, the higher the value of the option. Right? Makes some intuitive sense. If nothing ever changes, right? If everything has always been the same, delaying a decision by 1 year into the future doesn't buy you much, right? If nothing ever changed, it's probably not going to change in 1 year either. So I can decide just as well today as I can decide 1 year down the road. However, if things are all over the place, I have no idea what's going to happen whatsoever, deferring the decision increases in value, right? Because I have no clue right now. In 1 year, I know exactly how much hardware I need, and therefore, the option has more value. Let's come back to our scale out, our elastic scaling. If I build something that takes online traffic, right? I have high uncertainty. I'm building some mobile app or some website. I don't know. Do I have 1,000 users, 1 million users, 100,000 users? I have no idea. The scale-out option is highly valuable. If I build some internal app for 10 users, not as valuable. So bringing that logic back together, we realize something very interesting. Many people thought that architecture and agility are somehow opposites of each other, right? People felt that sort of architecture is the long planning, these big decisions you have to make, right? Versus agility is this kind of lucky go happy, right? We just kind of, we see how things evolve, right? But by detour of Black-Scholes and option pricing, we actually realize that the two things actually go hand in hand, right? The higher the uncertainty, the higher the value you get out of agility because you don't pretend you know everything up front anymore. But also the higher the value of the architecture options, because as I said, right, if you know exactly what's going to happen, you don't need the option likely, versus if you have high uncertainty, the value of the option goes up. So kind of very different point of view at architecture, right? And that also, of course, leads us to the question of when, one more second, when we don't need architecture, right? And I'll come to that. There's a second game here, and this is not a movie reference, but a TV show reference. Anybody knows this ridiculously bad TV show? Takeshi's Castle, yes, like cultural reference. If somebody doesn't know it, got to look it up, right? Very important. It's like this ridiculous game show where they're basically from Japan, where they make people do these little bit sadistic, actually not a little bit, these like very sadistic exercises. And this is called the Dragon's Pond or something. It has a name. Basically, people need to run over these stones, except some of these stones are styrofoam. And you can't see as you're running, right? And sometimes, if you're an enterprise architect, you feel a little bit like this, right? These are your vendor products, right? You're running across, you're buying all this stuff, you're building all these things, and some of your stones turn out to be styrofoam, right? That's going to happen. On the other hand, not running isn't an option either. So while having all these options and protecting you against sort of locking into the future, you also need to make some steps, right? If you don't place certain bets, you're never going to move. You're going to built something that could do anything and everything, and he probably built another JVM or something, but we're definitely not creating business value. So interesting dichotomy, right? It's like on one hand, you're selling options because there's uncertainty. On the other hand, you need to place some bets, you need to find some stability, and yes, every once in a while, you will step on a piece of styrofoam. Right? So who hadn't thought that architecture has something to do with Takeshi's Castle? Learned something for the day. Now we come to what I promised is, obviously I'm an architect, and I guess a lot of you guys are architects. The question then is, when can you safely, or most safely, ignore architecture and architects? And I kind of gave the answer with the options analogy is, if there's no change. Right? This thing is just like sitting there sort of, it's just like what most of our legacy systems look like in one form or another, right? They sort of kind of sit there, they don't do much. So if you absolutely have no change, if you get it to work somehow, you probably don't need a lot of architecture, right? Now the catch is that a safe assumption to make? And in today's day and age, probably not, because change doesn't just imply functionality change, but also environment change. Your library is going out of support, somebody finds an exploit, traffic change, many, many changes that can come. So the assumption that nothing changes is probably pretty rare. But I would say that's the only time where I could say, if nothing ever changes, if the thing works somehow, you don't need to hire an architect. Turning that around again means, architects should be dealing with change, right? Like these options, this uncertainty, and that's why I'm saying architects really need to deal with the first derivative. Our job is to maintain velocity. Our job is to speed things up. And the speed of a system is sort of the first derivative of where it's at, and that's why architects live in the first derivative, right? Here the first derivative is 0, because nothing is changing, so not much to do for us architects. However, even though this is what legacy systems look like, most organizations are not standing still. They're moving a lot, sometimes in circles, happens also, right? But at least they're moving, so architecture is needed. Now, if we think, okay, that's easy enough, right? Okay, a little bit of a long detour around the matrix, options theory, Takeshi's Castle, right? We come to the new understanding of architects, but basically, if you make it simple, our job is to bring change and to speed things up. The interesting part is, speeding things up isn't as simple as just going faster. Right? And I'll explain a little bit why there's a lot more to speeding things up and working in the first derivative. So it starts with the fact that if you look at classic IT, it's always built like this. There's an as-is state, and there's a to-be state, right? We want to replace our old CRM system with Salesforce. We want to move our stuff to the cloud. We want to implement a new XYZ system. There is an as-is, there's a to-be, there's a business case, and we know how we get from as-is to be. That's called a project, right? That's how projects are funded, and this is how IT fundamentally works. And the most important point in the project is right there, when things go back to normal, right? That's when the big launch party is, right? That's always say, hasn't anybody ever wondered about why we have the big party before actual users come to use the system, right? Well, it's a different kind of question, right? So in the large IT, when the thing is done, we have the big party, and that is because things go back to normal. Now, if you think about it, right, that is built on the assumption that change happens in compartments, right? Change is not the normal state, actually the horizontal up on top, where the first derivative is 0, that's called business as usual. And I always laugh about, if that's business as usual, projects must be business as unusual, right? So basically it's built on the assumption that change is abnormal, right? The change is kind of the nasty thing that you have to deal with, and you package it into these projects as much as you can with steering committees and approvals and reviews and project managers, all that kind of stuff to just make sure this nasty change doesn't get out of that little box, right? And big IT organizations are extremely good at that. Now, there's a problem with that. If you embrace our idea of change and options and the first derivative, you will find that the so-called digital world is built around constant change. Change is normal. Business as usual is change. And in the end, that leads to a very, very different setup. The key skill you can have on the left side is you basically need to be a good guesser, right? Because this target picture is all about, do you have the right target picture in mind? On the right-hand side, it's much more about being a fast learner. And that's why I sometimes call these things, the left-hand side I call the economies of scale, right? The bigger you are, the better returns you get of this project, versus the right-hand side are the economies of speed, right? The faster you can move. Now, the interesting thing is this is not wordplay, but it's a fundamentally different way of working. So as an architect, if we're there, right, you see the left-hand side has a lot of first derivative 0, the right-hand side doesn't have that, and that completely changes the ball game. There's another danger when you're trying to speed things up. And as I said, speeding things up is not just making things faster. If you have a nice steam engine and somebody comes along, right, you kind of might see the analogy, a traditional sort of enterprise, some digital disruptor comes along, right, and they zoom right past by you. What is your first reaction? Well, your first reaction is, well, we got to go faster, right? And I'm sure all you guys, or many of you guys, work for large, financial services or natural resources companies, right? The things you have here, and nobody has ever complained that the IT is going too fast. Right? So everybody likes the IT to go faster. Now, the interesting part is, how do you make that IT go faster? Well, it's very easy. You put more coals in the fire or more water in the boiler, right? More pressure, right? And that steam engine will go faster up to a certain point, right? And I'm sure a lot of folks who live in an IT, because I've been there, a lot of folks who lived in an IT that has to go faster know exactly what that feels like, right? There's more coals on the fire, more pressure on the boiler. Hey, the digitals can do it in half the time we do. We got to speed up, right? And you know exactly where that's going to go. It's going to go to the boiler bursting and the whole thing blowing up. So speeding things up is not just making it go faster, right? That is the definition of disruption, right? We talk about digital transformation and disruption. If this was incremental, by definition, it's not a disruption. A disruption is something that rewrites the rules, and you cannot reach that speed if you're following the old pattern and just trying harder. Somehow management, though, perennially seems to believe that that's the case, right? Does not work. You will burst the boiler. The other thing that you need to be very careful about is when you try to speed things up, it's most of the time things don't move so fast because there's friction in the system. And this is a very useful example of friction. These are the brakes on a car, a very nice car, right? So that's the only time friction is a good thing. Most of the time friction isn't a good thing because it keeps you from going faster. Now the problem is, your reaction might be, if you find friction, is, well, put more power, right? Just like the steam engine, right? If the engine just isn't running all that well, a quick solution is, bit more horsepower, a bit more gas on it, right? A bit more pressure on it, things will move more quickly. But it has the same adverse effect. The friction goes up. The harder you push, the higher the friction becomes. And ultimately, sort of some bearing will seize or something will blow up. So this does not work either. Pushing harder is not going to make you faster, or definitely not faster to the extent that you need to be. So as architects living in the first derivative and trying to get our first derivative up, so our speed, right, we are up against some very interesting system effects that are dangerous, right, because you can end up blowing up the boiler, or you can end up basically blowing up the engine, or just exerting all your energy because the friction becomes way too high. So if those are the things that don't work very well, right, let's look at some other thoughts around how do we actually speed up. And I look at three different kind of angles of making things go faster. And it's mostly around debunking sort of common views and substituting them with a different view, because as we said, more coals in the fire is not going to do the trick. So if you ask any project manager to speed up their project, right, they take out this magic recipe from the Project Management 101 class, right? It's the project management triangle, right? I'm sure people have seen this, and it sort of conveys the idea that a project has a certain scope, a certain number of resources, and therefore it takes a certain amount of time. I always say you have 1,000 bricks to stack up, right? You have one person, it takes you a whole day. If you only had 2 people, you could do it in half a day kind of thing, right? Except we're not laying bricks, we're building software. So careful about that. And then the most dangerous part of the triangle is this quality thing in the middle, and that basically tries to convey the idea that if you stack the 1,000 bricks with 2 people, but you do a shoddy job, you can get it done in like 2-3 hours, right? The idea is if you compromise on quality, somehow things move faster. Now, every software engineer knows that the best way to slow down a software project is buggy code base, right? Because that's where you spend all your time. So we have a little suspicion that this doesn't exactly work. On the other hand, it is so widespread. Right, this is where the mythical man month is, give me more resources, right? Kind of thing. We know that doesn't work. However, I still see this every day. People say, oh, we're going to reduce scope, we need more people, right? Maybe we shrink the testing kind of period, right? So unfortunately, this is as widespread as it's wrong. Now, the real ways to speed up a software project, many of us know, is having a very different point of view. Right? Not compromising quality, but there's our friend friction, right? Getting friction out of the system is actually going to speed things up. Inventory. Nobody likes inventory. What's the definition of inventory? Inventory is the stuff that you made that has incurred all the cost, but that hasn't been sold and hasn't generated any revenue. Now, you don't need a PhD in finance to realize that that is not a good thing, right? You spend all the money, you haven't gotten anything for it, right? We don't like that. Now, we often don't think that software has that much inventory because it's not so visible, but it does, right? Every Git branch is inventory, right? Anything that's not in production is inventory. This like, oh, it runs on my machine locally somewhere is inventory, right? This is all inventory. So reducing that makes sure that the effort you make actually goes to productive use. And then, of course, the best way to speed things up is to not build stuff that actually nobody needs. And every software engineer, when we talk to users, we know there's a big difference between need and want, right? I'm sure somebody wanted that car. It's a Mercedes with Swarovski stones on it, right? I'm sure somebody wanted that. Whether they needed that and whether it provided business value, different kind of question. So very different angles, right? This is a different kind of project management triangle. And of course, all these translate into the common buzzwords we use, right? The friction, that is, DevOps, continuous integration, continuous deployment, right? Take the friction out of our build system, reducing inventory, that is lean, comes actually out of the manufacturing industry, just right there. And agility is about building the things that have the most value first, right? And not build things that don't have any value, right? So these are classic ways for us to speed up. And as an architect thinking in the first derivative, those are the levers you have, not the levers on the previous slide. Now, bringing this bit back into our technical kind of world, I often ask people, now what's the first derivative of a software system? If you have a running piece of software, and we talk about this derivative stuff, what's the first derivative? It's the build and deployment system, right? Like the way you change, because in math, the first derivative is sort of what's your rate of change. Well, the main thing that determines your rate of change is your build and deployment pipeline. And it's interesting to see because we had some chats here from various cloud providers. I used to work for Google Cloud also. Is if you see a lot of the innovation is actually a lot of the attention is shifting from pure runtime and infrastructure, right? We have all the IaaS and VMs and containers and all that kind of stuff we have, right? A lot of the attention has shifted to deployment, right? Serverless is also very much about making deployment much more efficient. We have Fargate, we have Google Cloud Build and what they're all called, right? There's a lot more attention on the build pipeline, and that's because that's the first derivative. And I summarize this in a simple slogan where I say, like, if you really want to speed up your software delivery, if you live in the first derivative, your build system is equally important to your production system, right? Your first derivative becomes a first-class citizen, if you wish, and that's why people have, containerized, resilient, fully automated build pipelines, because that's your lever, right? That's what determines your first derivative, and that's how you speed things up, not by compromising quality or just throwing more people at it. Now, I hinted at that, so probably, these mechanisms are fairly well known, right? This is not the first time you're hearing about CI and CD and Lean and Agile, right? It's like all these kind of things. I just wanted to frame this a little bit. What I do want to spend a bit time on is about the topic where I said don't burst the boiler, right? Don't just like hit the gas pedal harder. Like how do you speed up? By looking at things in a very different way. So here's an article I actually wrote a little while ago, and this was from working for a big cloud vendor, but talking to CIOs all the time, and them making the argument and say, hey, you spiffy cloud people, that is all totally cool what you tell me. I need to be highly automated, I need to be really fast, I need to be iterative, feedback-based. I hear all that, but listen, I'm a CIO in a traditional company, right? And my boss doesn't talk to me about iterative and automation. My boss talks to me about the three things on the right-hand side, right? Security, nobody wants to be in the newspaper, right? That's the fastest way to the unemployment office, right? Nobody needs that, right? Availability, nobody likes to pay for IT that isn't running, and please, 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 don't spend too much money on it, right? So that's the CIO gets every day in and out from the CFO, from the COO, from the CEO. And we on the left-hand side talking about speed and things. So what I think is actually really helpful to put speed in context. And what I did in this blog post basically make the argument the things on the left are actually exactly the ingredients that are going to get you the stuff on the right. They're not two separate worlds, and that's what I mean by thinking in a different way or looking at things from a different perspective, right? They might seem as opposites, right? Very different kind of vocabulary, but in the end, they're closely related. Yeah, and I don't need to go through all of them because to you guys, it would seem obvious, right? It's like how do you get security? What's the easiest security hole, right? Is not having something patched, inconsistency, higher attack surface. So all these kind of things around how do you fix that? Automation, speed, and monitoring. And how do you become available while reducing cost? Well, rather than having hot standbys that sit around and cost you a lot of money, you provision on demand. You scale on demand, you fail over on demand, right? So that is the way that you reduce cost. And the main ingredient is speed. So speed does more than speed things up. So in the end, I guess I'm making two arguments for how speed is not just speeding things up, because on one hand, you can't just accelerate, right? That's bursting the boiler. On the other hand, once you speed things up, you get more than just going faster. So at Allianz, when I worked there a little while ago, we talked about server provisioning times. And because of long story contractual agreement, it was 8 days for virtual machine. A little embarrassing, right? That's how large IT works, right? And I always said, I want it done in 5 minutes. And to be honest, most insurance businesses don't need a server in 5 minutes. This was on-premise, right? Now we can have servers in 10 seconds everywhere, right? Then to be honest, they didn't need them in 5 minutes. The main reason I wanted them in 5 minutes is because that way I could be assured that it's fully automated. And because it's fully automated, I increase my quality and reduce my cost. Right? So it wasn't just about going from a few days to a few minutes. It was about working in a fundamentally different way. And I have a few more of those examples. Right? So the reason we like to go faster is not because we're in a hurry. Right? It's because it allows us to work in a very different way. And I think when we communicate to management, that's important. They always feel like developers are in such a rush. It's like, oh, I need to spool up a VM, in a minute. And people say, oh my God, a minute is eternity. I need, serverless. How many milliseconds did we have? 5 milliseconds, right? It's a little bit hard to explain to management, why your instances need to spool up in 5 milliseconds, right? If you work for bank or insurance companies, they're like, you know what? Insurance works on annual cycles, right? They have 8,000 hours in a year to figure out when their load spike comes, right? And you argue over a few milliseconds. So I think it's important to have that kind of conversation with management to say, this is not because I'm in a hurry, this is because it allows me to work in a very different way, right? And this is one way, right? For example, speed allows me to reduce cost, right? Speed also allows me to bring what I call one of the most important ilities. We have all these ilities as architects, right? Testability, maintainability, scalability, right? We often say architects deal with the ilities. Well, here's a new ility that I like a lot, disposability. Now, throwing stuff away is bad, right? You should recycle a lot of things. but you should not recycle your servers, right? This is where all things like immutable infrastructure, etc., come from. If you have a certain amount of speed, you don't need to recycle anymore. Because why do people always tinker and patch their servers and the whole cattle versus pet kind of story is? Well, because it takes them too long to get a new one. So once you speed things up, you can increase availability while reducing cost, because you don't need all those hot standbys kind of thing, and you can afford to throw things away and recreate them so you always have a clean base image. And again, speed is the main ingredient, right? If this takes you a few days or a few weeks, you would not do that. You would rather patch up what you have, versus if you have a new one in a minute, right? You gain this new important ility, which is called disposability. And I think that's probably, I would say, one of the most important architecture concepts we had in the last couple of years, that we can just dispose of stuff and recreate it without ever having to worry about it. Here's another point of view on what speed does, and in this case, in the context of automation, right? When you talk about automation to a normal enterprise, they think you're trying to get rid of people, right? Like traditionally, what have companies done for hundreds of years with automation? They reduced human resource cost. Well, it's like Ford Model T, the assembly line, the steam engine, right? We always eliminated manual labor with automation. So when you come and tell management, hey, I want IT automation, right? I want Ansible, whatever I have, kind of things, they think that's what you're after. And again, in IT, it's very different. We don't automate to sort of just get rid of manual labor, because I've never seen anybody in IT who's not actually busy. So I'm never kind of worried that we kind of automate ourselves out of a job. I've never seen people who have nothing to do. So no worries there. We have different motivations. And again, speed, right? As I said, the reason I want a server in 5 minutes is not because I really need it in 5 minutes. The reason I want the server in 5 minutes is because that way I know it is automated. And because it's automated, it increases quality. Also, it gives me some more confidence. I don't have to wonder about what server is going to come out, because to be quite honest, the servers with the 8-day SLA, the real question wasn't when is it going to come, but the real question was what is going to come, because half the time what you got was not what you actually ordered, right? That's a much bigger problem. So automation is not there to just replace human power. It's nice to get rid of the toil, but it's much more the repeatability, the confidence, the quality, etc. So again, kind of different look at speed, right? As I said, speed is not just being in a hurry. Now, of course, we talk mostly about speeding up technical things, right? But in the end, if you have a 6-month procurement cycle, it doesn't help you a whole lot that you can spool up new serverless instances in a few milliseconds, right? If you need months of approval, so you need to move the organization along as well, right? A lot of folks who bring DevOps into organization and agility, all these kind of things, they find this out the hard way, right? You're moving faster, you're agile, you have feedback, you have all these things, but the rest of the machinery doesn't move the way you move. And this comes back to the left and right picture that I had, right? They see change as abnormal, so if you're moving faster, that does not compute, right? As I say, this is the organizational null pointer exception, right? This is kind of the two things don't match up. So you have no choice but also deal with the organization. So I have a few thoughts around how you can do that. The first important part is when you're looking to make an organization go faster, it's tempting to look at the people, at the individual elements. And say, can't they just work a little harder and be more efficient, be a bit smarter, kind of doesn't hurt, right? That's like sort of the first inclination. And of course, that's a big trap. And the trap is nicely depicted there. This picture, shows us very nice cars, right? And the question is, how fast can these cars go? Well, probably at least 300, right? Or close to 300, not bad. How fast do they go? 25, 30, maybe, right? If the guy wasn't holding the camera out the window in the front, maybe they can go 35 or 40 if they're really lucky. So it's not a component problem, it's a system problem, right? And that applies to organizations as well. Don't fall in the trap of Can just everybody work a little bit faster? Can we have better people? Because that is, again, just putting more coals on the fire. You need to look at the system and fix the system, right? Put some lanes in, for example, right? Or, basically hiring better people, right? What does every organization that wants to speed up, what do they say? Oh, if we only had better people, right? Hiring better people is like putting more horsepower in the car, right? Is that going to help? No, right? Because it's stuck in a traffic jam. It's probably going to overheat because it's not moving, right? And the same will happen to the people you hire. If you hire high-powered people into a high-friction organization, they will also overheat, right? They'll get frustrated, and they leave, or they cause all sorts of trouble. That's usually what happens in my case, right? Because you have too much horsepower to go around. You're looking for stuff to do, so you just cause trouble. So fixing systems. There's one very important thing that I realized from working with organizations around getting them to see things from a different point of view. And I found out it's actually a known system effect. It's called dimensionality. So you will find folks who have a belief, and often experience and data points to prove it, that certain things are opposites of each other. Right? They have a one-dimensional view of the world. And here's the classic: speed and quality. And the reason, or the way you find out that they have this belief, is they have slogans like quick and dirty. Right? It's like, why does it have to be quick and dirty? Or like other way around, why does it become quicker if it's dirty? Right? It's just kind of, it's like, okay. Somehow they believe these things are on a single spectrum, right? Why is it not quick and clean? We commented on that before, right? So they believe these things are opposites. So one of the most powerful things you can do as a first derivative architect is show them that that is not necessarily the case. Show them that these are two dimensions, and probably if you plot, a little bit of math here, I don't think I'm going to get a Nobel Prize for this one, but let's see. I just basically plotted the left hand on the right hand side, but now you can have a whole different discussion, which is like, can I shift this thing? Can I give it a different shape? Can I move up, right? Can I improve quality without slowing down? Yes, I can. It's called automated testing and continuous integration, right? Can I speed up without losing quality? Yes, we know how that goes. It's also automation, rapid feedback cycles. We know these mechanisms. The biggest danger is if you talk about these mechanisms, for people who have the left-hand mindset, it makes no sense. It does not compute. Right? Like, oh, I have this cool thing, right? It's like it goes faster, but still has the same quality, or quality even goes up, right? I want my servers faster, so they're higher quality. To them, this makes no sense, because for them, these things are opposites to each other. It does not compute. As I said, the organizational null pointer exception, right? You will not get anywhere with the argument. So the most important thing you can do is show them that these two things are not, I always say it's not a Hollywood movie. It's not the battle between good and evil, right? It's not left or right. These things have two dimensions. Now I teach workshops. Actually, last year we did one here. I teach workshops where we go through this exercise. And one of the reasons I like doing the workshops, because I think I'm the person who learns the most in the workshop. So here is a draft. Well, actually, this is a flip chart photo from one of those workshops where we brainstormed about what do organizations believe are opposites that we know actually aren't. And then for some of them, we wrote the mechanisms on it that make it clear that they're not opposites. So speed quality was sort of my teaser example, right? But then transparency and motivation they have. Customization and low cost, that's a classic one, right? People think if it has to be cheap, it has to be all the same, right? As soon as you allow variability, the cost must go up. Sits very, very deep. The automotive industry had that belief for like almost a century until recently. Now you can have everything customized and it doesn't cost any more, right? Standards versus flexibility, right? People believe that if you standardize something, you stifle flexibility and innovation. Now, I would say cloud is the ultimate counterexample of that, right? It's like highly standardized, right? It's like, okay, by now you can get like 20 or 30 different server varieties, but in the end, cloud standardizes heavily, but it's the biggest innovation booster, right? Like platforms have shown that to be true. People don't believe you can innovate while maintaining low risk, and we know that, right? Be risk averse, but not change averse. right? Because they believe change brings risk, and so on and so forth, right? They think if they automate something, they lose control. A lot of financials I work with have that, like 4I principle, the belief if you have an automated deployment, it's sort of the root of almost all evil, right? They think sort of somehow automation voids them of control. The whole idea that somebody approves the automation, like GitOps and stuff, right? For them, it's very foreign. Right? Those are the conversations you need to have. Change and stability, sharing and monetization, right? That was for a long time believed that if you share openly, you cannot sell it because everybody has it right there. Now, we have open source, professional open source is one example, and a lot of my book material is another example, right? Most of what I write is openly available. People still like to write the book. So, long list of examples. I say the workshops are fantastic for this because people brainstorm these. So many, many examples where people believe opposites are given, but a new way of working shows that they're not. And you need to have this conversation in the organization. It's also part of the architect job, right? It's not just the technical stuff. If they're stuck here, as I said, you cannot have the conversation about your CI/CDs, serverless pipelines, speeding things up. Because when they hear speeding up, they hear poor control, poor quality, right? They hear very different things. So you need to bust out of this. Another one is speeding up is not linear, right? You need to ultimately shift gears. So I'm still in the combustion engine era, sorry, right? Electric car is a little bit smarter, right? But with a combustion engine car, right, the speed is not a linear thing, right? You go one speed and then you sort of shift gears into another speed. Now in organizations, that's equally difficult as it is to an engine. You need a clutch, right? You need to sort of disengage, shift the gear, and re-engage. And I have some slogans around this, and the one is that in technical architecture, the way we do this is we build an anti-corruption layer. If you have sort of things at different speeds that we need to get to work together, you have some legacy systems slow moving, you build this anti-corruption layer around it. I think it's an Eric Evans terminology, right, from domain-driven design. You wrap the old system so that the new system can move at a higher speed. Now, interestingly, this is one of many examples where technical architecture and organizational architecture actually very much look alike, right? So if we can wrap an old technical system to make the other side shift into second gear, we can also do this with organizational systems. And the one experience I have is whenever I talk to a large organization that's in one of those transformation journey, which these days is pretty much everybody, they will have somebody who is the clutch. They don't have that on the business card, right? But like at Allianz, I was the clutch, right? It's somebody who tries to make the old system and the new system work together. And usually you know that you're doing a good job if both sides are equally much complaining. Right? The establishment says, oh my God, you're just a cowboy ignoring all the rules, and then your team says, you promised us everything will be better and faster, but it really isn't, right? Then you're probably doing the best job you can. You will always find a clutch in those organizations. There's usually somebody who's highly motivated at bringing change, who's willing to do some windmill chasing kind of to get there, and has an inherent motivation to play that role. So that's an important part of shifting gears, right? You need to get this clutch that does a little bit of disengagement. Now there's one catch with these clutches, and that is you cannot be on the clutch forever, right? We know you need to shift in the other gear because if you're slipping your clutch all the time, good things don't happen. And this is one of the reasons I'm not a big fan of these two-speed architectures. So I think luckily they kind of came and went a little bit, right? They were all the rage like a couple years ago. We said, well, if you want to speed up your organization, well, why don't you speed up your front end? And we still see this with cloud. A lot of people move the front end to the cloud first because data residency and yada yada and legacy systems, right? But the idea that this was trying to portray that it's okay to have a sort of slow and stable on-premise kind of thing in the back, and then you put a nice sort of GUI, fast-moving, serverless, highly automated, containerized, whatever you have on the front, and that was seen as a good strategy. Now, I would say couple of comments to this is, the one problem I see, again, it makes this speed versus quality trade-off. right? Because it's sort of assuming that on the front end it's a bit more forgiving, so you can go faster and sort of compromise quality a little bit, versus the back end, that's our banking system, right? It needs to be absolutely watertight. That's why we do things slowly. So these people haven't broken out of this Hollywood movie, right, of speed and quality, right? That's the one pet peeve I have with this. And the other part, of course, I have is if you keep riding the clutch, you get a picture like this. These are not the tires, that's the clutch, right? It's because engine and wheels are not in the same speed. It generates just an enormous amount of heat, and ultimately the whole thing will blow up. Yeah, sorry, my talk is a lot of blowing up. I think I must have gotten that from Chris, right? So we have the boiler blowing up. We also have the clutch blowing up. But in the end, those are the resistance factors of speeding things up. So these two-speed architectures, they can be a reasonable starting point to shift into the second gear. But they're sort of like the clutch is slipping, right? And it's like, what do we say? What if you need something in the front end, one field that's not available in the back end? Two-speed architecture already stuck, right? Either you rewrite that piece of logic, right? Or if you need some change in the back end system, your whole two-speed thing is gone, right? And that's the grinding. So if you keep grinding, your clutch will burn out. And that means two-speed architectures are an okay interim stage while you're shifting. They're not a suitable target picture. It's not the way how you speed up your organization, unless you're selling clutches, maybe, right? Then you have a good business. Come to the last part, and I want to convey a little bit the message again that as architects, having to deal with organizational stuff can be a little bit tedious, because it's like people and emotions and all that stuff we don't like to deal with as much, but it's unavoidable, right? You got to. Otherwise, all your fantastic technology is not going to do anything, right? The silver lining is that the organizational systems behave very much like the technical systems. So if you understand technical architecture really well, you actually understand organizational architecture much better than you probably thought. And here's a classic example. I'm not going to take too much time, is layering. Right? It's like, name me one pattern, one architecture pattern that we like to use every time layering. We always layer stuff, right? Why do we layer stuff? Because it gives us separations of concerns, clean interfaces, clean dependencies, replaceability, right? You can swap your database out, reduces lock-in probably, right? Does all sorts of good things. However, anybody who's worked in a heavily layered system also knows it's like, oh, I only need to add that one field to my UI, and now I have to make a change in 4 layers, right? Because I have my UI layer, I have my business logic layer, I have my persistence layer, and I have my database layer, and suddenly that little change propagates across all layers. Not that great, right? So layers have a lot of structural benefits in the way you organize and compose your system, but they have behavioral downsides, right? They bring latency and more effort to drive change through this. So most organizations, because they're used to a slow-moving world, are optimized for the left-hand side. They like layers, exactly for the same reasons. Separation of concerns, organizations like very much because they can hire specialists, right? Sort of the antidote of the full-stack person, right? And the organizations traditionally like specialists. Replaceability, what do we call that? Outsourcing, right? Take one layer out, put another layer in, right? Take our ops people out, put some cheaper folks from a country you've never heard of in, right? Like, very common in big IT, right? So they like the left-hand side, but they're facing the same disadvantages on the right-hand side, right? It takes a long time to trickle things through, right? And that's one reason for that is that layering leads to local optimization, right? Because you look at each piece on its own, and people will optimize their piece. And that's a good thing, right? I mean, people are supposed to optimize what they do, but they optimize their box. They don't optimize the whole thing. And I would say that is the biggest change if you're trying to sort of turn up the dial on these organizations is you need to get away from the structural view to the behavioral view. You need to understand the price you pay for these structural advantages. And that's where slogans like delayering are coming from. And you need to start to look at global versus local. As I said, large organizations are optimized locally. Every box is optimized, but nobody sees end-to-end. Right? And you can see this easily, right? It's like if you talk to another department, you wait like 3 months, you need to fill out endless forms, right? All that kind of stuff because they optimize locally, but they never account for the cost they incur right? I often suggest to organizations, when you look at the budget of a department, you should really look at the internal cost and the cost they incur somewhere else. Well, let's say you have a security department or something, a legal department. How much cost do they actually generate inside the other departments? Nobody knows, right? Because it's not written down anywhere. So if you want to speed things up and work in the first derivative, you need to start to optimize globally, because that's where the biggest lever is. If you look at organizations, and let's say you want to cut costs or speed things up, if you look at the boxes, like the departments or the systems, you will not find much. And the reason for that is they've gone through this exercise 100 times, like every budget cycle, right? Every budget cycle, they look at every box, they get 10% discount from the vendor, they negotiate, right? They shave a little bit of headcount here. They looked at all their boxes and they have optimized all their boxes like 50 times over. So you will not find much. Where you find it is between the boxes, right? It's the famous slogan, the lines are more interesting than the boxes. It's the same as the Ferraris, right? Don't look under the hood of the Ferrari. Look at how the whole thing fits together and why all these Ferraris are stuck in traffic and are not moving. So this is how my last comment is, if you really want to shift gears and speed things up, you need to see end-to-end across the layers of abstraction, as well as through the value chains and the departments, right? And a lot of things like value stream mapping, etc., of course, come exactly out of this corner. And maybe to conclude again, to highlight that these things are they're not subtle nuances. They're not like wordplay or pretty pictures and you say, oh, optimize globally, locally, all the same. No, they're actually completely the opposite of each other, right? Because the local optimization, how do you know an IT organization who does that? They're always in a product selection. Right? They're like, oh, we need a PIM-PAM solution. Do we have CyberArk or this and that? Oh, the cloud, they spend all day debating between the 3 different cloud providers, right? It's like, oh, but this, I get a sustained use count discount here versus I have committed instances over there. They spend all the day talking about product selection. Everything is departments, projects, utilization, and cost. And you can see on the right-hand side, the vocabulary is exactly the opposite. So these are not nuances, they're fundamentally different ways of thinking. And as I said, it's not about more pressure, more coals in the fire that doesn't work, right? We know we have different mechanisms, like DevOps, CI, CD, all these kind of things. The most important part, though, is to bring this view into an organization that these things that they believe to be opposites aren't actually opposites, right? You need to crack that nut of the dimensionality. And once you have done that, you can look at things in a different way and realize, two-speed architectures are not, the greatest thing ever. Local optimization has done, quite a bit of good so far. But if you want to move into the second gear of your organization, you need to start to optimize globally. And again, that's not just speeding up. That is really shifting a gear and putting another gear in. With that, I hope there was a little bit of a little peek in my mind where I am currently with thinking about roles of an architect very differently, right? We talked about architecture is there to bring options, right? A little bit of Black-Scholes and options theory in there. Then we realized when we don't need architects at all is if there's no change. Rarely happens these days. So if architecture is there to bring change, right? Architecture and Agile goes actually very much together. A lot of thoughts about how we bring change, including it's not a linear kind of thing. It's about switching gears, and especially it's about seeing things from different point of views and different dimensions. Now, you've been a good audience, so I think you deserve a beer. Me too, perhaps. I have time for maybe one question or so.